Brothers and sisters of internet, it is your host today, Caveman Math. Today we will be learning about factoring, the wonderful world of factoring. How can you factor? What is factoring? First, we must go over what is factoring, honestly. Factoring is a method for solving equations in algebra like the ones you see here, and essentially it involves determining what we multiplied to get the given quantity. So what do we multiply to get this? It's going to be, the answer is going to be in parentheses always. So factoring gives us an equation, basically an equation in the form of a product of expressions that we can set equal to 0. If the product of two or more expressions is equal to 0, at least one of those expressions must equal to 0. First, we need to factor out any common terms. See if there's a greatest common factor or a GCF. Here, there is no GCF that I can see, but there is common factors here. But here, there's no GCF. Like you can't multiply 7 times 2 and then get 31. You know, that's not how it works. 7 times 2 is 14, not 31. 7 times 3 is 21, not 31. 7 times 4 is 28, not 31. So you can't get any of that. You can't get 20. You can't get any of that. So essentially, what we do when we approach factoring questions is we go about them like this. It is called the AC method. That was the key, but here. This is the AC method where we look at the last term of the equation and we do, let's say, okay, let's do the factors of 18. 1 and 18, we have 9 and 2, which is 9 and 2. 9 times 2 is 18, but 9 minus 2 is also 7. So now we can actually plug this in and find it. Look, check this out. We can't plug it in for x. Sorry, don't disregard what I just said. But here, check this out. You can do, because you want to find a product that multiplies into this. So here, let's try it. We have actually x, and then, never mind, wait. Okay, let's set this up first. Let's do x plus 2x, minus 9x minus 18. All right then. So now, oh, this is a bit weird. What is this? Okay, now we have this. Now we can start actually factoring this. So we factor out x for this part first. We go x and then x plus 2 and then minus 9, because you can factor out 9, so this becomes 2. But when you factor out minus 9, it's actually plus 2. So now we have this. Now you're wondering, where are my answers? They are located here and here and here. So now we just put these together. We put x plus 2, which is as is, and then we put x minus 9. There we go. Now we have something that's factored. Right, now if you wanted to portray these as x terms, then you would have to do this. You'd have to do x plus 2 equals to 0, and this would essentially become x equals minus 2, because this 2 goes over there. You distribute it, and now you do it with the other one, which is 9, and then you put 0, and then now you have x 9. So this is how it's portrayed as an x term or an x-intercept. All right, boys. Let's go on to the next one, which is this one. Here we look back at the AC method and we track back our steps. We do 14, right, the end term, and then we see the factors of 14. We have 1 on 14, and then we have 7 and 2. Now 7 and 2, 2 minus 7 is 5. So that means that checks out. Let's set the equation up, because this is how you factor by grouping. Now you do negative, actually, yeah, let's do positive 2p and then negative 7, because we want this to stay negative, right? So negative 14, All right, there we go. This sounds good. This is 7p. Do not mistake that. Negative 7p, negative 14. There we go. Now we can start factoring this. So we factor by p. This becomes p plus 2. And now this becomes negative 7. Yeah, we can factor at 7. Let's do p plus 2. Now we have this factored. We have negative 7 and we have p and we have p plus 2. So our answers are p negative 7. Oops. And then we have p plus 2. Now these written as x values are p minus 7 equals 0. And we bring the 7 over. And now it's just p equals 7. And now this one, p plus 2 equals to 0 is now p minus 2. So p equals minus 2. That's poorly written. P equals minus 2. There we go. Now we can go on to this one. Oh boy, this is a big boy. It has a big number, 63. Let's go. All right, let's do the factors of 63. Let's get this down. We have 63. Now here I'm just going to do 1 and 63. I already know because, 9 times 7 is 63. So knowing that, we have 9 and 7, which are easy factors. But let's check. Is 9 plus 7 16? Well, yeah, it is. So when you add 9 and 7, it is 16. So that checks out. All right, let's set this up for factoring by grouping. We have negative 7x, because we want this to be minus and plus. Whenever I see this, I instantly default to minus minus, because minus minus plus, so it's 1 minus and 1 plus. So I just do minus on the two ends and then plus 63. All right, let's split this a little bit. All right, let's try to factor this out. So first we can factor x. Let's go for x. X minus, so it's just x and then minus 7, and then we have minus 9. Yeah, let's do minus 9, and then we got x minus 7. All right, now we can actually just find it right here as we did before, and now we have x minus 7, and now we have x minus 9. This is very basic factoring. I doubt you guys need this in math 3. This is math 2, math 1. You guys learned this in algebra 1, but all right, let's keep reviewing this. We have x minus 7 equals 0, which makes x equals 7. And now we have x minus 9 equals 0, which makes x equals 9. There we go. We found both of these. Now let's draw the line and go over here. Over here, we have something very simple. We have just to factor out k. So let's just do 7k plus 9 and then factor out k. And basically what this gave us is 7k equals negative 9. Now you just divide by 7. And now you just got k equals negative 9 over 7. That's the answer. I'm going to calculate the decimal really quickly. Be right back. All right, this rounded out to roughly 1.29, and that is how you solve that. Now let's go over to some harder ones over here. For example, this one. All right, let's get it. All right, boys, we come back to this one. This is a little bit of a twister, you see, because it's not like the ones where they do not have a, what's it called, a coefficient, like a leading coefficient. The ones that do not have a leading coefficient, or the ones that are just x, x squared, those are easy to solve because you could just group them up by using the last term and just doing the AC method. But these ones, you have to actually split this into something that will add to 17 but can also be divided by this. So in this case, I can just go 2b squared plus 14b, right, plus 3b, right, plus 21. Wow, that's crazy. Now, essentially, at this point, what we do is we just, factor it like normal. We do 2b factored by 2b, because actually we're going to do this by 2b because 14, we can get 14 out of there. So let's do this. We do 14, we got b plus 7, right? And now we can actually get this out of here as well, because 7 times 3 is 21. So 3, and then we got b, and then we got plus 7. So we have to be b plus 7s, but these are the answers, right? Always. So we got 2b plus 3, and then we got b plus 7. There we go. That's our answer, right? And now we just have to turn these into x values. Now what you do here is you do b plus 3 equals to 0, and essentially what that turns into is 2b equals to negative 3, and then at which you divide 2. So that's just b equals negative 3 over 2, right? That's one of them. Now you do b equals negative 7. Let's just straight up, and that's just b equals negative 7. So our two values are b equals negative 3 over 2 and b equals negative 7. All right, let's get to this one right here, because actually never mind, this one looks a little bit easier because I want to hit the 10-minute mark. I don't want to bore you guys for too long because I want enough examples so that you guys do not get confused on tests. Let's do these two, 9 and 11. All right, let's start. So with this question in particular, we are looking to fulfill a parenthesis essentially with this, like 5p. The ones with the leading coefficients, you always have to put the leading coefficient in front of the parentheses. So you're just going to draw your parentheses like this. This is kind of like a guess and check method, but let's try for better understanding. So here we have to see, okay, what can I do that's 5? Okay, 5 times 2, 10. All right, let's do this. All right then, hold up. I don't know how to explain this really, but I guess I'll just solve it and you guys can see this. So I factored out p, and then I got 5p plus 9, right? And then negative 2, and then 5p plus 9, right? Because negative 2 times 5 is 10, and then negative 2 times 9 is 18. So we got 18 here, right? All right, this is actually going to solve back because I'm going to check this and we're going to resolve it so that I know that I wrote this right. So you guys can see me solve this back to the original equation. All right, let's solve this back to the original equation to make sure that I got this, because why not? I'm not really sure about this. So if you're not really sure, just always resolve it. 5p times p. So 5p times p is 5. Oh, that's a bad 5. That's a bad 5. That's okay. 5p squared, right? 5p squared, and now 5p times negative 2. So 5p times negative 2 is negative 10p. And then you have 9, and 9 times p is just 9p. And then 9 times negative 2, which is negative 18. Right? Now you just have to subtract them. So you essentially have the same thing that you started out with. That is the point of factoring, because you come out with the thing you started with when you multiply them back. Now we just have to turn these into the p-values. I'm just going to do this mental math because why not? P equals negative 9 over 5. And then we got this one, which is p equals 2. There we go. That is how you factor that. And I'm going to do one more just to make sure I hit the 15-minute mark because I do not want to bore you guys. Let's get started. Now this one is a bit different, you see, because you have a factor that you can pull out of each individual one, which is b. So they have a greatest common factor. That's the point. You're trying to find a common factor so you could simplify into a product. Let's take b out of these. So we got b, and then we got 3b squared 5b plus 2. All right, that's fairly simple. Let's see how much more we can split this apart. So here I see that we can actually split this 5 into 2 and 3, because why not? Because you can keep simplifying it. All right, here, let's try this. So we go, this is technically supposed to stay in here, so I'm just going to do the right part and just keep the b here, because why not? 3b, because correct math, you need to solve it correctly, or else you can't just solve it in your head and then put it down. You need to show your work on paper. That's what math is all about then. So now you have some space to work with. You can actually just start factoring this out. You could do b, and then let's do a b, another b, because you could factor this b out of that b. So it's just 3b minus 2, and then because this is minus, right? So it's just minus 1. So 3b minus 2. Alright, well, this looks simple. That's the solution, I guess. Yeah, so this is a solution. B times 3b minus 2, and then you got another b minus 1. Now the thing is, when you're writing the answers for these, it's actually, because you have a b right out here, right? So that b is actually equal to 0. So one of your b's is actually equal to 0. And then because you have a b right out here, right? Because you have an extra factored out b. So that b is actually 0. It counts as one of the x factors. And then you have the 3b, and then you put that equal, and then you have 2. And then you divide them, so you do this, and then it's b equals 2 over 3, and then you have b equals, well, you have 1. Now that is how you factor. I hope that helped you guys, and I hope all of these videos help you guys in the future. Thank you for watching my channel. Thank you for your endless support. I'm sorry for the late videos. It's been a fun summer. See you guys in the next school year. This has been Caveman Math. I'm out.